Okay, so today, talking about solving systems of linear equations and linear inequalities by graphing. So, solving, let's see if I can find the top of the paper there. There it is. Solving systems of linear equations and linear inequalities by graphing. So we're only going to do two examples with this section because it's a longer process when you have to go through and solve by graphing because you have to graph every single one. So for every single system, there's going to actually be 4 lines that you have to graph. Alright. So now, graphing with slope-intercept form is what I think is the best way of doing it. So we're going to take a minute and go over some of the things we need to know about slope-intercept form when it comes to graphing. So we talked about slope-intercept form a few weeks ago. Again, graphing with slope-intercept form. So what does slope-intercept form look like again? Y equals mx plus b. Y equals mx plus b. Now, in that format, the two important things are your m and your b. Now, m is again for your slope, which again, last time we talked about slope, we talked about as rate of change. We can also talk about in terms of the change in the change in y over the change in x. So I'm going to put the little delta symbol. It's a triangle. Change in y over change in x. If you want to write out the word change, that's fine too. But delta, that means change. So change in y over change in x. The reason I'm writing it this way is because when we deal with slope for graphing, we're going to have to look at the change in y and the change in x because that's going to tell us what direction to go as we graph. And then for B is our, what again? Oh, no, M was our slope. B's our slope. Intercept. It's our y-intercept. B is the y-intercept. Now, when you go to graph it, you can graph it as a coordinate point. For the y-intercepts, it's always going to be a 0 for the x, and then whatever the b is. So 0, comma b, if you're graphing it as a point. So again, wherever it's intersecting the y-axis. So those are the basics you need to know in order to graph. Now, which thing do you graph first? Is it the slope or is it the y-intercept? You want to graph the y-intercept first. Graph y-intercept first. Then use your slope to find more points. Again, you got to remember, when we did our slope-intercept formula last time, I told you that think of B as your starting point, right? Because it's whatever our value is at x equals 0. So it's our starting point. It's giving us a point on the graph to start with. And once we have one point on the graph, the slope tells us where we can go from there. So B is always our starting point. Our y-intercept, that's where we're starting from. So now, we're going to do an example. And this example is going to be a system. So we're jumping straight into the system. Because we already talked about when we graph a system, where they intersect, that's going to be our solution. We talked about that on day 1. I showed you an example of 3 graphs. Now all we're doing is getting to the part where we're showing how to graph so that we can find that solution. So the first example that I want to do is y equals negative 2x plus 3, and y equals 3x minus 2. And then over here off to the side, I'm going to go ahead and draw my coordinate plane. Again, it doesn't have to be perfect. Draw a couple lines off. I draw like 5 marks in each direction. That's, you might use your standard. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, if you're dealing with bigger numbers, you might want to wait and see what the graphs are going to look like before you draw your graph. But for most of the ones that I'll use in here, if you go out 5 in each direction, it should be big enough to fit what we need it for. So, let's graph these two equations. So, I'm going to graph the first equation in red. I like color coding. And I'm going to graph the second equation in blue. All right. So, for the first one, we have to identify a couple of important things. Again, we always start with the starting point, our b value. So, where is b in this first equation? It's the 3. So we could say our y-intercept is at 3, which would mean as a coordinate point, we could say 0.03. So we go over here to our graph. We find our coordinate of 0.3 on our y-axis, right? There it is. There's our first point. That's where we're starting from. Then we need a slope. So for our slope here, we have the value of what? Well, 3 was our y-intercept. Our slope is... sorry, the one that I have circled in red. We got to do that one first. So, negative 2, right? Now, when you go to graph it, you want to think of it as a fraction. So, negative 2 is the same thing as saying negative 2 over 1. Or, if you want to, you could even do it the opposite way. You could have flipped this. It doesn't matter if the negative goes on top or on bottom. So I'm going to write it both ways. And I'll explain why in just a second. Because this is telling us what direction to go. All right. Normally, I'll go ahead and put it on top. So here we have negative 2, which that top number is telling us our y change. So up and down. So this is going what direction? Down. Yeah. So this goes down because it's negative. This is telling us right or left. So that's going to the right. So we're going from our original point down 2 to the right 1. So we're going to go down 2 to the right 1. And we can graph our next point. And we can do that as many times as we need to draw a straight line. So then from there, down 2 to the right 1. Down 2 to the right 1. Now you don't have to go all the way out here. But again, you can go as far as you need. Now, I wrote it the other way as well because we could also go backwards. If we put the negative on the bottom instead, this would now be telling us up and to the left. So again, we can do the slope backwards. Go up 2 and to the left 1. Now, we didn't have to do this for this graph, but let's say our starting point was way down here. Well, then we could have gone to the right because we've been off the graph, so then we would have to go backwards. So again, if you put the negative on the bottom instead, it's still the same thing. There's still only one negative value. Both of these are equivalent to negative 2. So this is our first line. So let's go ahead and connect the dots. But now we have a second line. Because again, this is a system. So we have 2 lines that we're graphing. So the second one, we do the exact same thing for. Again, our starting value, B is where? Where's B for this one? Negative 2. So again, if we were to graph this, this is at the point 0, negative 2. So coming over here, go down to negative 2, we draw our point. Now, we also need a slope. What is the slope of that second line? 3. So again, thinking of this as a fraction, this would be 3 over 1. Now, you know how I also wrote it out a second way here? There's a second way I could write this one as well. What's the other way that I could write this where I'd have a positive 3 as an outcome? If they are both negative. Right? You know how I move the negative sign from here to the top to the bottom? Here, again, negative 3 divided by negative 1 also gives you positive 3, right? Now, again, the reason why I do that is so that we can also graph going the opposite direction. So, let's start with the first one. So we have 3 over 1. 3 over 1 is telling us we're going up and to the right. So, up 3, 1, 2, 3, right 1. Look, we already found our point where it's intersecting. But again, I want to make a nice straight line, so I'm going to graph a few more points. So, up 3, 1, 2, 3, to right 1. If I want to draw some points to the back, going backwards, I'd then be going down and to the left. So down 3 and to the left 1. So I got some points. I can draw my straight line. So now, where did they actually intersect? This point right here. What point is that at? 1, 1. So my solution to both of these is the point 1, 1. That is the solution to the system. Again, wherever they cross, that is our solution. Now, we also need to take a look at some inequalities. Now, we talked a little bit about inequalities before. There are 5 inequality symbols. When graphing, we really only deal with 4 of them, but there are 5 inequality symbols total. There's our less than sign, that looks like that. There's our less than or equal to, that looks like this for tomorrow. All right. Now, I'm going to leave a little space in between because I'm going to write something in between here in just a second. So now I have greater than, and then I have greater than or equal to. And I kind of line these up so that I could make kind of like a chart almost. Not. Now, the 5th symbol, which we really don't use a lot when we're graphing, is not equal to. Again, it's an inequality symbol because an inequality symbol is anything other than just an equal sign, right? So less than, greater than, less than or equal to, greater than, equal to, and not equal. Those are our inequalities. Now, when graphing, we're going to focus on these 4 here. All right? So, first looking at that top line. In both of these, where we have less than and greater than, when we go to graph these on a coordinate plane, what type of line do we end up having? Anybody remember? So going back to algebra now. When we graph them, what happens to our line for these? Is it a solid line? No. Because remember when we do let's go all the way back to a number line for a second. If you were to do these on a number line instead, remember how you have the open circle and closed circle? Right? These had open circles, these had closed circles, because these are not included, these are included. Well, with a line on a graph, we don't use open circle, closed circle, we use a dashed line or a solid line. So these two get a dashed line. You could also say dotted, that'd be fine, dashed, dotted, whatever. dashed dotted line. These two with the or equal to, they get the solid line. Now, also, I like to graph in slope-intercept form. So, if we have either of these two, the ones that are less than, when we have our slope-intercept form, we're going to shade to what side of our line? Above or below? If it's less than. Below. So, in slope-intercept form, we can shade below the line. So, less than, shade below when in slope-intercept form. Alright, whereas for greater than, if it's in slope-intercept form, and we have a greater than symbol, we're going to shade to what side? Above. Right? So this one's below, this one's above. Now, again, the reason why this works is because y is by itself in slope-intercept form, right? Y is by itself in slope-intercept form. So if you have a y that is greater than the rest of the equation, it's going to be everything above. If you had a y that's less than the rest of the equation, it's going to be everything below. So again, it makes it easy if you graph them in slope-intercept form for inequalities. I highly recommend, anytime you have to graph an inequality, change your equation to slope-intercept form first, and it'll make it easier to shade at the end. Otherwise, does anybody remember another way to shade for graphing for these? So if it's not in slope-intercept form, what you have to do is you have to plug in a value that's on either side of your line. Once you plug it in, you have to see, does it give you a true statement? If it gives you a true statement, then you can shade on the same side. If it doesn't give you a true statement, then you shade on the opposite side. So again, it adds a couple extra steps to the process. If you change it to slope-intercept form first, then you can just base it off that y value. All right. So now, we have our main idea there. Let's take a look at a problem. It is an inequality. Sorry. So, just like on the last one, we're going to have two inequalities here. So I have y is greater than or equal to negative 1/2 x plus 2. And I have y is less than 3/2 x minus 2. And just like on my last one, I'm going to go way over here off to the side, draw my x and y axis. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. I got room for some extra ones on this one. Alright, that's fine. So, same way that I did the last one, I'm going to graph that first equation in red, so it's easy to follow along. I'm going to graph the second equation in blue. Now, I like to do this one slightly different. You know, I graphed it as I went the first time. On this one, let's go ahead and pick out all the important information first. So, on that first graph, we need, of course, our y-intercept. Where's our y-intercept for this one? 2. So it's at 2, or you could say the point 0, 2. Our slope on this one, negative 1/2. Which, again, you could read that as either negative 1 over 2 or 1 over negative 2. Both ways work. All right. The other important information here that we need to know is Is this a dashed line or a solid line? Solid, because it has and equal to. And what side am I shading? Above or below? So it's greater than, so I'm going to shade. If it's greater than, I'm shading above. I like making these notes before I do my graph so that I don't forget to do any part of it, because it's easy to go and graph it over here and use the wrong type of line, forget about shading, all those different things. So again, if you see that's an inequality, I like to make those notes first so that I know, hey, I need to make sure I include these things on my graph. Now, for this one, so we're going to positive 2. So here's positive 2. My slope is, again, I could look at it as negative 1/2, negative 1 over 2. So that's telling me to go down 1 and over 2. Down 1 and over 2. And again, I can do as many times as I need to draw a straight line. Or I could go the opposite, up 1 and back 2. Again, as many times as I need to draw a straight line. So this is my line. And again, it's a solid line, we said. So I'm just going to draw a solid line. I wasn't very straight with that, but you can get the idea. And finally, I have to include shading. And I'm shading above the line. So everything up to the top. Now, I got to do the same thing with that second one. So on the second one, what's my B value? Negative 2. So B equals negative 2, which again I could say that's the coordinate point 0, negative 2. What's my Y value? Sorry, not my Y. My M. What's my M? My M? My slope. 3, 2. Okay, yeah, 3 over 2. So 3 over 2. So, other things I need to include, is this one solid or dashed? Dashed, because it does not have the and equal to, so it's not going to be included. So dashed line. Again, if you want to call it dotted, that's fine too. And then am I shading above or below? Below, because it's a less than, so I'm shading below. So shade below. So, let's graph this line. Negative 2. So down at negative 2, I'm going to draw my first point. Now, you can also do the open circle thing if you want to here, because again, this line won't be included. So if that helps you remember to do a dash line, that's fine too. You know, I drew all these as just dots. If you want to draw all these as open circles when you do the dash line, that might help remind you, oh, hey, I got to do a dash line at the end. Again, it's actually okay to do that, because remember, nothing on this line is really included. So, for the next point, we're going up 3 and over 2. 1, 2, 3, over 2. Hey, look at that. We found a point where they intersect already. But let's keep going, because we want a straight line. Up 3 and over 2. Up 3, over 2. And we can also go backwards by going the exact opposite way. Instead of up and over to the right, we could go down and over to the left. So 2 negative directions. So down 3 and over 2. Again, this is a dashed line. So, looks something like that. And then we're going to shade everything below. So, this side's below, so everything below. So now, where those two shadings overlap, that's our actual final solution. So our solution is all this part here where they're overlapping. Now, it also includes anything that's on the solid line here, because that's in both sections, the solid line's in both sections, but not on the dash, because again, this dash line is not included. So anything in the shaded area or on this line, those are the things that are actually included in our final answer. All right? And that's it. Any questions from these notes? So tomorrow we're going to start seeing some word problems. So we're going to take everything that we did last week, along with some of these, and we're going to start doing some word problems with them. And I'll give you some time at the end of class to practice them as well. Then on Thursday we're going to do some more practice. On Friday is our next test. All right? And it's going to include everything from these two sections. Again, expect the test to only be like 10 questions at most. All right? Now, I think we got done a little early. Let me stop this.